access control models. They all share the same goal: keep the wrong people out. But the philosophies behind how they do it couldn't be more different. Pick the wrong one for your environment and you're either bleeding data or strangling your own users. Today we're breaking down when to use each. Think of it like a single building with 4 floors, same structure but 4 completely different security cultures operating inside. By the end of this deep dive, you'll know exactly which floor your environment lives on. Let's start on the ground floor. Section 1, DAC, Discretionary Access Control. This is the model most people are familiar with because it's built on individual choice. In DAC, the owner of the resource, that's you, decides who gets access. You have the discretion to share or withhold any file you create. It's flexible and familiar. It's how your personal laptop works, how Google Docs functions, and the foundation of standard NTFS or Linux permissions. When you run a chmod command in Unix or set folder permissions in Windows, you're exercising discretionary control. You are the data owner. But here's the catch. Owners make bad security decisions. DAC assumes every user is a competent security administrator. Spoiler alert, they aren't. One careless share and your sensitive data is loose. Once a user has read access, there's often nothing stopping them from resharing it further. DAC is perfect for agile, collaborative teams. It's the absolute worst choice for classified networks or highly regulated environments. Section 2, MAC, Mandatory Access Control. Now we're entering floor 2. Forget everything you knew about user choice. This is the system's house. MAC takes the decision away from the user entirely. The system, the operating system or the network, enforces access based on strict labels. Every resource has a label, and every user has a clearance level. If your clearance doesn't match the label, the door stays locked. No overrides. This is the Bell-LaPadula model, focusing on confidentiality. The first rule, no read-up. You can't see information above your pay grade. The second rule, no write-down. This prevents a high-clearance user from accidentally or maliciously leaking secrets to a lower security level. Then there's BIBA, the integrity model. Rule 1, no read-down. You don't want dirty, low-integrity data corrupting your high-integrity system. Rule 2, no write-up. Low-clearance users can't modify high-level data. It's rigid, it's expensive, and it's built for life-or-death security. You'll find MAC in Linux, military networks, and top-tier intelligence systems. It sacrifices user experience for absolute control. Section 3, RBAC, Role-Based Access Control. Welcome to Floor 3, the corporate standard. This is the model of who are you and what do you do. RBAC stops asking for individual names and starts asking for job functions. Permissions are attached to roles, and users are assigned to those roles. When a doctor logs in, the role doctor grants access to patient charts. If they move to research, their role changes and their access follows suit. This is how Active Directory groups and AWS IAM roles work. It scales beautifully for enterprises with thousands of employees until it hits a wall. Enter role explosion. This happens when you create a new role for every tiny edge case until your hierarchy is a nightmare to manage. And watch for role creep, users retaining old permissions as they move departments. Without constant auditing, RBAC becomes a security hole. RBAC is best for stable organizations with clearly defined jobs. It fails when you need to make decisions based on context, like time or location. Section 4, ABAC, Attribute-Based Access Control. Welcome to Floor 4. This is the most flexible, data-driven model on the menu. ABAC doesn't just look at who you are. It looks at attributes of the subject, the object, the action, and the environment, all in real time. Is it 2 a.m.? Is the user logging in from an unmanaged home laptop? ABAC can say access denied even if you're the CEO based on the context. This is the engine of modern zero-trust architectures. Think Azure Conditional Access or AWS IAM policy conditions. It's powerful, but it has a cost. Complexity is the enemy of security. If your policies are so complex that nobody can audit them, you're just trading one risk for another. Governance is vital. ABAC is best for cutting-edge cloud environments. It's overkill for small teams who just need to share some files. Context is everything. Real environments rarely run a pure model. Most modern systems are RBAC for the baseline, with ABAC layered on top for the contextual edge cases. The exam wants you to know each in isolation. Production wants you to know how to combine them for defense in depth. Which floor are you on? Exam traps. Don't mix up Mac with your OS. And remember, Bell Lapadula protects confidentiality. BIBA protects integrity. Get it straight. If the question mentions clearances, classifications, or the system enforces, you're looking at Mac every single time. Roles and job functions, that's RBAC. Context like time, location, or device health, that's your ABAC hook. Owner decides, DAC. Easy. DACs, Mac, RBACs, ABAC. Owner decides, system decides, role decides, context decides. Get those 4 mental hooks set and stop guessing. Full CISSP breakdowns, hands-on labs, and gamified missions are waiting over at zerodaylabs.tech. Level up your career. Class dismissed.